guys should have already checked number 2. Were we in agreement on composition? Okay, number 10, let me give you just a second. On A and B and C and D, some of you would have tried to go too far. Some of you would have tried to go too far. You cannot combine anything because they do not have like denominators. And if you try, they'd be gross. You cannot combine anything. You can, I don't know, write him over 1 and then multiply. Tops and bottoms, I suppose. You should have multiplied by the reciprocal, and that's why the order changes, but there's nothing to simplify. And if you tried crossing out stuff, you were killing poor little kittens. X squared and x squared does not reduce because that has a +1. It would be grouped. And those factors are very different. Similar, but very different. At the very, very end, how on earth is the domain in between 2 and -2? I'm sorry, it's not in between. Bigger than 2 and bigger than negative, I should say less than or equal to -2. I'm thinking the number lines and about how it's these 2 branches. Why couldn't it be 1 or 0 or 1.1 or -1.798? The square root. So if you notice our domain problem, it still totally works. X squared minus 4, the radicand greater than or equal to 0. You could add the 4. Still greater than or equal to 0, but when you plus or minus square root both sides, the positive square root, the inequality stays the same. The negative square root, the inequality review flips. They just wrote it super snazzy with the absolute value of x is greater than or equal to 2. We could have also just written it like this with an or. Number 18. Did you do the notation properly? It was F plus G, what? Of. Whoo, not times, not multiply, right? F plus G of, which is why it was F of plus G of. You had to plug that into the box for F, plug that into the box for G, and then carefully combine. Were any groups able, just in general, raise your hand if your group was able to help someone through a mistake, like we caught something. Did any group catch something for anyone? Okay, 2 groups, and that's better than none. It's better than none. 32, now they were compositions. Let me give you a second for A and B and C. You already checked, you're just making sure that you guys were right. And for someone who did mess up, get something wrong, can you find your mistake? Did anybody kill a seal? Did you distribute your negative? Ah. It's okay, I was grading pre-cal tests last night. From Friday? From Thursday? Thursday. There were many seals that died. Many puppies. Some puppies. More seals. On the difference quotient problem. Ugh. Number 42. Check out the very end. Remember, if you have this wrong, you're not going to have time necessarily to bust all this stuff out. Get the answer down. And then part of your responsibility before test day, which is on the calendar, I think it's next, where are we at? 4-9? I think it's next Tuesday. I'll go check the calendar. You guys go ahead and peek. Look at the end first. Get the right answer down first. If you don't have time in class, ask it as a question. But if there's still not time, you don't feel comfortable, it's your job to figure out how to do it correctly. Or to come in after school. You don't have to do it alone. Hopefully my class is set up so that you never feel alone. If you're willing to reach out. If you're not willing to reach out, of course you will feel alone. Oh dear. That's a life lesson. It's a hard one though. Tuesday. Tuesday is our test. Number 44, you guys hopefully are already seeing it. It's not F minus G times, it's F minus G of. So F of 1 minus G of 1. It's not F times G times, it's F times G of F of 4 times G of 4. 52, I think, Tony, was it your group about the one possibility? You guys were thinking maybe there were other ways of doing it? Was that you guys? Does anybody have another variation on 52 that you think is also correct? Because you could always check it by taking a composition. Anything other than G being 5x plus 2 and f being 4 over x squared? Oh, okay. Yeah, Kim, you guys check it and let's see. What if g of x was 5x, and then what'd you make f? What do you guys think? Does it work? How would you check it? Wouldn't you do f of g, right? So g will get plugged into what spot? F's x, right? And then does that work? Yeah. So good. That also works. Anybody have another one they want to try? Go on. I'm so sorry, bud. Hold on. It's sounding good so far, though. So f of x, 4 over x, g. Good. What do you guys think? If you put g into f spot? Yeah, that works. That works. Now, if you guys notice both Kim and Johan's answer, weren't the pieces a little more complicated? Does that make sense? But they worked. They were a little more complicated. This would be the simplest way in the sense of the pieces being simple in and of themselves. That's like a little linear guy. That's a little 4 over x squared guy. So they just, the book or the answer key, or even myself because of my training in calculus, I would have chosen the simplest pieces. But these do work, yeah. Yeah. Any other ones you guys want to check? No? Okay. Coming back. 60. You were supposed to take 3 plus 2, plug it into your n function, n of capital T of t. So you plug it into the arguments, hopefully not killing any. Do you guys see what I mean by killing seals and puppies? So many people would mess up this one that we've talked about. So many people would mess up something here. And I don't mean necessarily like half of you would, but I mean take all of my different classes, quite a few students throughout the year would make mistakes. Then you have to carefully distribute, simplify. Let me give me a second. Give you a second. Doing well, sir. They're grading their homework, but besides that. You can do it right now. That's okay. Yeah, you guys ready for a dress code pep talk? The room part, but like, you have any questions? You'd be like, no, we're good. See what I mean? Like, that would have been a lot nicer for him. Do you have any questions? As opposed to just glazed over, just kind of like you're half alive. Anyway, yes, we just recorded that. That's fun. Okay, so, I mean, B was plugging in 0.5. Did you guys get the correct labels? Pause, pause, pause. Are you labeling your numbers and not just giving numbers? In word problems, there's context. It's not just 653 who knows what. It's 653 bacteria, right? And then in letter C, did you figure out that time was hours? Did you label it with hours? Now, hold on. Wait a minute. What did a lot of you guys not like in letter C, at least if you're reading the answer key? What do you see them putting? Quadratic formula. You got to be kidding me, right? But hold on. After they said quadratic formula, what else did they put? Didn't they put a decimal? And what do you usually need to use in order to get a decimal? Don't you have to use your calculator? So was there another way to solve this without using the quadratic formula if you were allowed to use your calculator? Oh, what were you thinking, Gavin? Yeah, you totally can. Kylie, right? Yeah. Yeah. I mean, if you like the quadratic formula, it's fine, and I wouldn't have done the decimal. But if you don't like the quadratic formula, how can you do this in your calculator? How can you find the zeros of a function? Right? We did that. Pre-calc graphing calculator handbook. I gave it back to you. How do you find the zeros of a function? You make y1 equal to this guy. And where's that zero function? Well, y equals is where you put the, right? Y equals is where you put the function, but where do you put the actual, or where do you hit the actual or find the actual zeros operation? Second calc. I think technically it's a second, then the trace button, right? It gets you to the calc menu. And then you can use the zeros. What are the questions if you're in your calculator? What are the questions that it asks you again for zeros? Left bound, go to the left. Right bound, go to the right. Ooh, to answer those questions, don't you have to have your zoom so that you can see the crossing? Crossing? How does it look on a graph when you're finding zeros? Where is it crossing? The x-axis. These are x-intercepts, right? So you're going to look for the x-intercepts, and then ultimately the x-intercepts end up being, ooh, that's right, it doesn't like that. Sorry. Double sorry. To remind myself to talk to Mrs. Christensen. Okay. It's going to end up crossing at 1, 2, 3. There-ish. And it's going to end up crossing at. So would Zoom standard have worked, guys? Yeah. Because Zoom standard would give you negative 10 by 10. You know what I mean? Like, it would give you these 2 points. Then you would see your parabola. You might not see all of it, but you would see, there you go. You would see the parabola crossing through. And then left bound, right bound, left bound, right bound. Got it. Good. Is that okay? Yeah. Well, if it's a word problem where you're using your calculator, technically no. You know what I mean? But what if it was a test problem without calculators being allowed? Maybe we should review the quadratic formula really quickly. So we reviewed the decimals. The decimals, don't get decimals from the quadratic formula. Use your graph. Find the zeros. If you're allowed to do decimals, if the multiple choice are decimals, you would be using a calculator. That's okay. But what if you can't use your calculator? Okay. What if no calculator? What do we do? Quadratic formula. Works for A equals B equals C equals, it's nice and in order, ax squared plus bx plus c, t's, whatever, at squared plus bt plus c equals 0. And then how does it go? X, nope, it's not x, t. T equals negative b plus or minus square root b squared minus 4ac all over 2a. Done. Almost done, right? Almost. Negative 2 plus or minus the square root of, I would have a negative times a negative, which would be a positive. I have 4, 12 times 30. Oh dear, it looks like 130. There we go. I think 3 times 30 would be easier. Mental math, 90. 90 times 4 is 360, and 360 plus 4 is 364. That was fun. Over 6. Almost. Oh man, I would love to just take out 2's all over the place. Kittens would die. But you could see in this 364, this wouldn't actually be the final answer. That wouldn't be the multiple choice thing to match, because doesn't stuff go into 364? Couldn't you simplify that radical? 4 goes in, long division, 4 into 3, nope. 4 into 36, yeah. 9, 4 into 4, yeah, 1. 91, well 3 doesn't go in, 9 and 1. 17, something gross like that. Long story short, there's no perfect squares in there. So we could make this negative 2 plus or minus. We should make this. Square root of 364 becomes 2 root 91. Why does this save me from killing a kitten? Why am I allowed to do this? Because I'm taking it out of every piece. A better way of looking at it technically would have been if I had factored out a 2 and done negative 1 plus or minus. This would have been the most legal way, where I'm double checking, making sure I'm doing it right. Guess what would happen if you had plugged in, or if you did plug in, negative 1 plus root 91 over 3, and negative 1 minus root 91 over 3. Dun, 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 dun. I just mean checking the answer. Yeah, I would leave it like that. Wait, no! Why? This is a word problem, and the answers have meaning, right? And we're supposed to be solving for t, and t is time. Which time makes sense? Positive time, negative time, or both? Negative time doesn't make sense unless you're going backwards. What? Time travel? Not today. All right, so, well, it doesn't always have to be time travel. It could just be you're talking about, well, we started the experiment at 8, but maybe something was going on at 7:30. Like, it's not always backwards. Never mind. This is not a conversation for right now. Guys, did you have any questions on section 1.8? Yeah, Kathleen. Yeah. Of the compositions? Okay. Let's start with 44 first, just because it's a specific one. Why was this whole section, 43, 44, 45, 46, why was it weird? They didn't give you actual functions. When else did they not give us actual functions that we didn't like? A homework problem that we all hated, they did not give us actual functions. Number 10 from section 1.7, where they gave us points and they didn't give us a function. You didn't like that one either. Remember? So many people just skipped it or did something wrong. Anyway, oh, it's getting in that. Never mind. Sorry, squirrel. 44. They gave us a graph. And Kathleen, you said A specifically? Or just 44 in general? Okay. They give us F and they give us G. The key, I think, to all of these is still going back to notes yesterday when I said we're going to get, oh, I don't know. That one? Yes. When I said this can get really confusing if you don't remember your formulas. So the first thing is, do you recognize the notation? Do you recognize the notation and do you know it well enough that you won't get tricked when it comes to something weird like 44 or 43 or 45 or 46? So the notation would say whenever you see F plus G or F minus G in parentheses with a 1, I would say the very first thing you need to do is attach that to the formula and say, okay, this is the same thing as F of 1 minus G of 1. Okay, first thing. Second thing is to say, well, what is F of anything talking about on a graph? What is G of anything talking about on a graph? What are they talking about? The y values. So remember, so simple and yet so hard. So remember, this is really asking for the y of f when x is 1. Ugh. Minus the y of g when x is 1. That's technically what it's asking for. So what they're saying is, well, when x is 1, what's y? Of the f, it's 2, and of the g, it's 3. And that's why the final answer for this one was -1. Does that make sense? So the notation getting there is hard, and then the notation of, wait, we're just looking for, sorry, we're just looking for y values? Oh. So we can find from this graph, we can find f of 0, f of 1, f of 2, f of 3, f of 4. Technically, we could make little linear equations and even find like f of 0.5 or f of 0.2, not just eyeballing, not just guessing, but actually knowing them, because you can make a linear equation from any points or 2 points. And then this one, the only difference would be you're doing multiplication, so f of 4 times g of 4, which is why when x is 4, they plugged in 4, and they plugged in 0. I think this one was 0. Does that sound right? Yeah. Okay. So that's the general gist of that whole section. And some of you, I bet others had questions, you just didn't ask it. Silly goofs. Ask your questions. Having the answer written down is not the same as understanding. But domain. Let's just go here for domain. I know there was a question somewhere. Where are the ones with domains? Yeah, right? Okay. In general, looking at all these domains, I'm going to go ahead and take a picture of it so I can write all over it. In general, taking domains, what are we looking out for that's going to make the domain anything other than all real numbers? For right now, 3 things. Square roots, denominators, so fractions with denominators, with x's down there, and the one that's in parentheses that we haven't really done yet, but I showed you already, logarithms. And then there's trig, but that's just a whole nother. Okay, so denominators. Oh, I see a denominator. Guess what? X can't be 1 or -1. Just in general, for f, right? What can't x be? 0. No square roots, no denominators. Cubed root. Do you guys know how to write that one? This is x squared. Just ignore the 3. X squared with what kind of root? Oh, cubed root. But is there any domain problems for odd roots? No. So he's fine. X needs to be greater than or equal to 0. Radicand has to be greater than or equal to 0. Oh, it's a cubed root. He's fine. Ooh. X plus 4 needs to be greater than or equal to 0. So x has to be greater than or equal to negative 4. Can we all, just making sure. I know, I was grading pre-cal and I'm taking it out on you just a little bit. How do we solve for x? It's the first time I've seen this mistake over and over and over and over again in the pre-cal test. First time, ever. How do we solve for x? Subtract the 4. Okay, whew, we're not adding the 4, right? Okay, good. It's x greater than or equal to negative 4. I saw it over and over and over again. It was so weird. Subtract the 4, right? We're good? Like minus to get it to the other side? Like you take away from both sides what you do to one side, do to the other? We're trying to cancel out the 4. Just making sure. There was some gap of something somewhere before my class on the pre-cal test. Oh, your quiz. I have it. We need to get back. One person from every group, go to the back and get a correction paper for everybody in your group. Thank you, Kyle, for saying that. Regular pre-cal was the test I was grading last night.
You were having.
Yeah. But you guys had some common mistakes too, and some seals and some puppies and some other things died. Oh, there's a seal that died. Oh, there's another seal that died. Oh, there's no work shown, so I couldn't even give partial credit. Oh, so sad. Ooh, there was an over 100%. There was another over 100%.
I hope it was me.
If we have a test next Tuesday, maybe we should do corrections before then, huh?
Yeah.
So maybe corrections by Friday. That way you have the weekend to study like what you know that you got stuck on. When you hear your name, come on down. Let me pause the recording. We do. For f of g, you have to plug in, like the x goes in g first and then in f. So we would look at g first. When it's this order, we'd look at all the g's first and then think about plugging into f and see if there's anything extra that comes. So for f of g, I would say, x has to be greater than or equal to 0 before you ever got to plug in. So it had to work for this before going into that. So even though it goes away, because of the original function, x, the domain does have to be greater than or equal to 0. The other way, like what if you were doing g into, or f into g? This guy, all real numbers. Yay! Plug it in. Oh no. Now x squared plus 1 has to be greater than or equal to 0 for domain. Yeah. Doesn't matter, negative, positives. Except for plugging in one? Oh, except for, well, a 1th root, yeah, isn't a root, so you don't have an idea. Yeah. Okay. Does that kind of work at least for right now? Okay. But feel free, we can go over this more because it's hard. It's not easy. When you hear your name, now let me go ahead and pause. If anybody does need to be taking notes, corrections due on Friday for the quiz. Homework number 9 due tomorrow, so therefore, section 1.9. Section 1.9, what was the notation thing that I was worried of you guys messing up? The -1, is it a power? No. What does it mean? Inverse, f inverse of x, not reciprocal. If you wanted to ever raise a function to a power, you would have to do it like this on the outside. You would have to do it like this on the outside. So definition of inverse, that's the page over here. How do you test whether or not two functions are inverses of each other? When you plug, combination of functions, when you plug a second into a first, the second function into the first, everything should be undone. All the addition, subtraction, multiplication, division, powers, roots, everything should be undone and only x remains. Or if you were to plug the first function into the second function, everything should be undone except for the x. Only the x remains. And so the way that we do that is switching the x and y's, solving for y, but when you solve for y, it is not the same as the original. It is the undoing function, the inverse function. We have to call it by the inverse name. So no longer f of x, no longer just y equals, but f inverse of x. And then we talked about very end of yesterday, because this x's and y's switch, the domains and ranges switch as well. The x's of the original are the y's. Did I say this backwards? The x's of the original are the y's of the inverse, and the y's of the original are the x's of the inverse. So for every single individual ordered pair, the x's and the y's will switch, flip. Switch and flip, flip and switch. Okay, so let's get to the example. And it's a super easy example. Aw, that's no fun. It's okay though, we'll do it fast. Some of you could mental math it, I bet. If the example says, find the inverse of f of x equals 4x, then verify that f of f inverse of x or f inverse of f of x are equal to the identity function. Let me go ahead and just help you with some of the words. The example is easy, and you'll see that in a second. But identity function, do you guys remember who that is? The identity function. It was one of the parent functions from section 1.6. Yeah, it's just a line. What line? Y equals x. Good. 0, 0, 1, 1, 2, 2, 3, 3. Y equals x. The y's are the x's. So the identity function, they're talking about y equals x. You might see that sometimes. And remember, each of these are compositions. You're plugging in. So first of all, okay, well, how do we find an inverse? Switch x and y. Wait, there is no y. Okay, so maybe what should be our first step? Rewrite it with a y. Now what? Well, we might get confused a little bit. Let's call him f, just to remind us. But now we switch x and y. And as soon as we switch x and y, now we're talking about the inverse. Now, does this equal the inverse? No, we have to get y by itself. And all we have to do is divide by 4. So y equals x over 4. And we name him his new name and say, no, 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 you're not, no, you're different, obviously. So we're going to call you f inverse. Now, how is it the undoing? Why do I call it that? The undoing of the original. I know that sounds intense, huh? Because when we go to verify, when we go to test, we're going to plug, well, the first one says f of f inverse, which means f inverse gets plugged into f's input. So y equals 4 times, who's the input? This guy. Is this guy the undoing of that guy? Yes, because what happens right now? The 4 is reduced and you end up just with x. Okay, well, what happens if you go the other way? So f inverse is the undoing of f, but is f the undoing of f inverse? Well, plug into the y of the inverse. And what goes into the input spot of him? A true inverse function is the undoing of the original, and the original is the undoing of him.
Yes.
Look at that. Drama and math. Who knew it? Okay, so this has been verified. These two functions are inverses of each other. This is the original, that's the inverse. Dun, 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 dun. But what needed to be undone from the very beginning? Just multiplication by 4, right? Just multiplication by 4. I'm good? I'm good. You're good. We're both good. Okay, so just multiplication by 4 needed to be undone, true? But do you think functions ever get harder than just being 4 times x?
Yes.
Yeah. So, it's going to get harder. I totally led up to a page that's in the future. Lo siento. Before we get to those harder functions, though, really quickly, let's go ahead and talk about the graphy thing. We just talked about the identity function, yeah? Who is that again? Y equals x. Good. So guess what? The identity function is important. Not only because we verify inverses by it, we plug one into the other, it's the undoing. We plug the other into the one, it's the undoing, right? And it gets back to the identity function. But the identity function is also super helpful because on a graph, check it. If you have your f, the f inverse is going to look like, what's that thing called when we flip over something? Reflection. This is going to be, the inverse is always going to be a reflection in the x, in the y, in the origin. No, no, and no. What does it reflect across? Think. The identity function. Why does it cross? Why does it reflect? Why does it flip over the identity function? Because the y's and x's switch. That might make sense to some of you. It might not make sense to others of you. But that's okay. The fact remains that an inverse function will always graphically be a reflection across the y equals x line. And I want you guys to highlight somehow this fact right here. I mean, the whole thing is important, but do you see how this graph f has an a-b point? A is an x and b is a y. What's going on in the inverse? Why is it BA all of a sudden? The x's and y's flip, and that's what we do algebraically, and that's what's going on with the domains and ranges, and that's what's going on with the graphs, and that's why we see this reflection. So if they give you a graph of an original, how can you do it for the inverse? Take it piece by piece and say, okay, this piece needs to flip. Okay, there he is. Oh, that's actually not the original. Lo siento. This is the original. This little piece is going to flip. This little piece is going to flip. This little piece is going to flip. You can take it piece by piece. You don't have to do it all at the same time. It gets really overwhelming, and in homework you'll get really overwhelmed if you try to do the whole thing sometimes. So take it piece by piece on each side of the y equals x and say, okay. And I just started with the tail. I would have started with him and said, hey, flip you. Okay. Not in a bad way. Reflect you. This one. Flip to the other side, flip to the other side. Just do it piece by piece. It makes life a little bit easier. But anyway, that's what's going on with graphs. But let's get back to, okay, the algebra. What needed to be undone? Sorry, Lacey, from the beginning. Who's the original? What needed to be undone? A subtraction and a multiplication. What do you see in the inverse that makes it look kind of right? There's a fraction, aka a division by 2. Oh, multiplication undone by division. I think algebraically that should make some sense. And there's a what else? An addition by 3. Now, not all of you would have guessed, like right off the top of your head, that's the order it should be without doing the math. But maybe at least somewhere it makes a little bit of sense that subtraction undone by some sort of addition, multiplication undone by some sort of division, yeah? But what they were asking us was really not to do it algebraically or to prove it by plugging in. This problem just says sketch it, so I already did. Guys, how could you tell on your graphing calculator, I have a y1 that's here, a y2 that's there. That's my original, I believe, my f of x. How can I tell that? Because I know math and whose slope is higher. Which means he's going to be what kind of line? Higher the slope? Yeah, right? We know that from skiing or watching other people ski, right? The higher the slope, the steeper it is. Okay. So we have our f of x, we have our f inverse of x. How could you use your graphing calculator to show that these are inverses? I mean, some of you might be like, oh yeah, it looks like it. What else could we do? What else could we graph? What if we graphed a y3 and what if we graphed y equals x? Good job, Gavin. Right? Because if we graphed y equals x, and if it went perfectly, ooh, unlike my line, oh look, yay, perfectly through, what could we then say? Yeah. And if you want to be super, super, super snazzy, couldn't you technically even, like, I don't know, calculate the value using second trace? calculate the value of f. I don't know, pick an x. What did I pick? 1, 2, 3, 4. Couldn't you calculate a value and have the calculator plug in 4? I mean, you guys could plug in 4 also, but get 5. And then couldn't you also do it on the other function and plug in a, what would you have to plug in to check the point? And calculate the value and have it be 4 and be like, yeah, buddy. All ways of checking to make sure graphically that these things are inverses also. So we can check algebraically. We can check graphically if you're allowed to use your graphing calculator. If not, have fun doing it by hand. But what if we get something like this where we have to deal with functions numerically? Ugh. Wait. This page isn't meant to be hard. But take a second, digest what it's saying. But I bet you could even fill in the blanks. You guys are cool like that. Do you need my magic. Mrs. Christensen is magical. Okay. When you're having fun, why'd you guys fill in the blank? Booyah. That makes sense. Haven't I already been talking about it? So if you just have the points, what are you going to do to get the other points? Easy cheesy, right? Lemon squeezy. All right. I think this is about our last page. And then just practice problems. Okay. We're all right. Kind of, sort of, maybe. I haven't done some practice problems, but I want you guys to go ahead and... stressful. Pause. You're all right. Inverses are going to pass something called the HLT. Special ones do. HLT is the horizontal line test. Which you guys know how to do horizontal line tests. Long story short, you can call inverses by a special name, one-to-one or invertible, if they pass the horizontal line test. I think you guys are good to have that homework fully attempted by tomorrow, but I will give grace on as to how far you get in homework. Does that make sense? So you do have to have like every single problem written down. If we get to a section where it's invertible and you're like, go ahead and stop there and it'll be okay, but still submit your pictures. Sound good? Out of here. Bye, guys. No.